Hello, my name is Chuck Reif with the Central Region Grid Methodology Advisory Team, and this presentation is going to take you through the full version of ForecastBuilder. This is the GUI from the first thing you'll see when you first run ForecastBuilder. It's basically asking you to choose a time period to run the ForecastBuilder procedure over top of. You're also able to choose between the full and light version, and where to start your forecast process, at what level of the ForecastBuilder you want to start with. And additionally, there's optional items that may or may not be configured at your office for aviation grids and fire weather grids. In the future, we hope to have these all available to be easily included in an all-encompassing forecast process. Basically, you have two different approaches you can use for the forecast builder. There's a short-term approach, which includes the current period through period 1. We think of this as just like an ESTF update. In fact, one of the key ESTF tools, a data load and blend, is included into the forecast builder. You can use that to consider initializing the foundation and semi-dependent top-down grids, or the seasonally dependent top-down grids, to bring in the latest OBS and short blend / con-short data. For the long term, period 2 through day 7, in Central Region, we are automatically cronning this twice per day, once at 530Z and again at 1730Z, and mostly using blended 0Z and 12Z model guidance, respectively. After that has run, go ahead and take the time to inspect the initialization, look over the forecast database and what's been loaded in there, look for targets of opportunity, where you get the biggest bang for our buck when it comes to making adjustments. Make collaborative adjustments with your neighbors and try to keep things pretty seamless across county warning area boundaries. And remember, it's always safest to start with those foundation grids, and that those are the default grids that are loaded up when ForecastBuilder runs. For this example, if you're on a day shift, it'd be running for period 2 through day 7. You're going to want to start with a tomorrow time period, that's period 2, and running through day 7. Start with foundation, run the full version, and again, we'll skip over the aviation and fire weather grids at this time. Once you hit OK, it sends you to step 2, which is the choose the weather elements to populate step. For this example, we're going to go ahead and run it for all weather elements. And again, in Central Region offices, these grids will be initialized for period 2 through day 7, twice a day, 530Z and 1730Z. Pretty much just like it's doing now for the days 4 through 7. It's just been extended all the way back to period 2 using the same process. And also note on that GUI, there's the initialization plan there, so you know what will be copied into the forecast database. Essentially, it uses the super blend, and then as model data is available, it uses the short blend and con-short nearer in time. And then finally, the OBS grids are copied in where they are available, with some interpolation done between each different set of data. Okay, so we've got a video example of this in place. For this example, I've gone with the full version, and I'll try to show you a little bit of what the ESTF does and also the extended portion of the forecast. So we're going to run it all the way from today through day 7 and start with the foundation grids. So I've already fired up GFE. I pulled down through the Populate menu the Forecast Builder procedure, and this first GUI is the one that comes up with the defaulted to full and change the times I want to run it. So when you do that, it automatically loads in the foundation grids in the background here. And then you choose all on that next step. For this example, that's what we've done. And we're going to see it load in the latest super blend data and con-short / short blend data for the different portions of the forecast. And then finally, the OBS data at the very beginning. And also between those data points, it is interpolating there, so you have a more smooth transition between those. Also note in this example, we have hourly pops that go pretty far out in our office, so you'll also see pop 12 grid in here to help us to coordinate with our neighbors. That's an option that was set up initially in the configuration, and other offices that are set up that way might have different configurations that help it to keep a standard procedure but still localize it to your office practices. So you'll be collaborating, saving, and making edits as needed, looking for those targets of opportunity. And this step will take the bulk of your forecast time, just like forecasting prior to Forecast Builder. You're going to spend most of your time deciding what kind of changes you're going to make and making those adjustments and making sure you stay in collaboration. Just this process will be an easier one since all your neighbors are all starting at the same time, all starting with the same starting point. So it should be a lot easier to stay in a relatively seamless matching up with the neighbors. So let's look at that in a video example. Basically, all the grids are there, ready to be looked over. In operational mode, you will likely have ISC on, so you can compare and see how your neighbors initialized as well, and ideally this will have come in pretty seamless. Sometimes there might be glitches, though, if one office might have missed a data set that was important to creating the blend. So those might stand out as being non-seamless. And some adjustments can be made to fix that. And definitely, if it's something that happens more often, more than a few times, it's something you might want to talk with your GFE focal point or ITO, and they can contact us as well at the GMAT team. We can provide support to make sure that you're getting all the grids you need into your starting points here. Okay. Also, while you're looking over the forecast grids, from the common starting point database, don't forget to look over the snow ratio grids and collaborate those as well. This is going to be very important to your snow amounts later on. Snow ratio, just like QPF and temperature grids, are considered foundation grids, and these are ones that you are expected to oversee and edit as needed. And the goal is to have the accumulation grids derive from these foundation grids. Therefore, editing will not take place on the accumulation grids, but they'll take place in the step before the grids that go into that, and that helps create and maintain an internal consistency to your grids. Snow ratio, for our purposes, is considered a conditional grid. That means assuming snow falls, it's the ratio to water of what the snow is. There will be training modules provided and available on using snow ratio. And so once your collaborate edits and fine tunings to those grids are done, go ahead and press OK. Just remember, if you did change your max T or min T's, don't forget to run the diurnal procedure over the time frame for when you made those changes. At this point, step 3 pops up. It'll be the top-down grid phase. You will not see this step, though, if hourly temperatures in your database are all above 40 degrees. However, if you are in a situation where top-down grids could be needed, this stage sets up. Though for simple rain and snow scenarios, you can just press OK to skip this step. It's not needed. However, there are situations where you might have mixed precipitation in the forecast. Therefore, you might want to consider having either the max wet bubble off, prob ice present, or prob refreeze sleet, or a combination of those 3 grids also available for your adjusting. You can initialize those using the top-down grid blend that is detailed here. And just to go over these, the max TW aloft, wet bubble aloft, is used for warm layers above the surface. Prob ice present is used for the loss of ice aloft, example getting dry slotted. And prob refreeze sleet is used to help catch those shallow, very cold dome in place. This is all developed off the POWT methodology, which has been successfully in place for many years now across a good portion of the region. I think we're up to 8 offices using that operationally now. And this has been put into the Forecast Builder as the best way to have one process to incorporate the science necessary, the top-down science, to produce the best accumulation and weather grids as the end result. And remember that those max wet bubble aloft and the prob refreeze sleet are initialized as part of the process for periods 2 through day 7, twice a day at 5:30Z and 17:30Z. And note that the model initialization, so you know what's being copied into the forecast database. And I did want to mention also that there's a road temperature grid that will also load up. You can see that here in the upcoming video example, where that road temperature allows you to edit that if needed, and you can therefore help control where the procedure will place the icing potential there in your weather grids and your ice accumulation grids. So let's go ahead and watch this video demonstration in action. Step 3 is popped up here. We'll go ahead and run with all 3 of those grids. Go ahead and check them all and have those in place, ready to have those initialized and then ready to be edited and collaborated. These are all available in ISC with your neighbors, so you can collaborate directly on these top-down grids if you're using the full version. And you can see they're all being populated. Also on the screen for reference, you will have some of the model data that's available as well that you can compare them to. So at this point, you want to check those over, collaborate with your neighbors, and save them. And once you're satisfied with them, you can press OK to continue. The road temperature grid does not automatically initialize, though. There's no model data we can use to set up the road temperature grid. So that's something you have to manually put in, either create from scratch or assign value into those grids. There are a couple websites listed, or some ways you can look. You can use your road sensor, local road sensor data to put that in if you want, if you're using it in the near term. Also, you can take into consideration how cold the nights are leading into that, and that will certainly be an indicator of sub-freezing road surface temperatures that you can also use to guide you in populating this grid if you think it might be a situation where icing due to liquid precipitation falling on the frozen surface could be a concern. Okay, so we'll have those all collaborated and saved. We're going to press OK to continue. At that point, ForecastBuilder then will check the integrity of the foundation grids and also any edits that you made to those grids. It also checks those top-down grids. Other grid updates at this stage include apparent T temperature, T grids. The RH and TD grids are checked and run. Max RH and min RH are run. Pop 12 is created. TD afternoon and TD morning are created in offices that use that. And in fact, we created for everybody. And if you're an office that uses it, those are available for your uses and any IDSS you might do with those. But you can consider this process, this point right here, a finalized procedure. You're finalizing all the foundation grids, all the grids that go into the derived grids that are the latter steps of the ForecastBuilder. It ensures internal integrity to our database. So step 4 then comes up, and this is the step where you create the precipitation types and accumulation grids. Typically, these default values are pretty good, but if you want to change from stratiform to shower, you can adjust that. If you want to choose either rain or drizzle or both, you can choose that as well. And there's a separator value via QPF to determine your rain and drizzle. And you have a temperature threshold down here for all snow, temperature threshold for all liquid, and then you can coordinate these changes if you do make any changes to these temperatures below. You want to coordinate that with your neighbors so you don't stand out too much with that as well. Now a video example of going through this stage. And for this example, we're running it directly from step 2, where it now goes into deciding whether or not you used to do any top-down grids. Since it had no temperatures for this example below 40 degrees, it's gone ahead and skipped the top-down portion and went right to the finalized portion. So it's finalizing and checking all the integrity of the foundation grids and the edits you might have made, and going to step 4. And again, we just go ahead and use the default values and let that run. So the first thing it does is create the showery precipitation. So it puts in the probability of type showers in there for you, have that all created, and now goes through to snow amount, ice accumulation, and sleet accumulation. In the ice accumulation ones, you'll also notice that it creates the ice flat accumulation and also ice line accumulation. That's from the FRAM model, which is done by 2 of the forecasters in Central Region out of the Topeka office, and they recently had their study published in the Weather and Forecasting, one of the recent editions of that. So that's part of the sound scientific algorithms that we have working in the background to get the most out of our foundation grids when it comes to forecasting, certainly things that are of high sensitivity to our DSS users. Okay, at this point you want to look those grids over, press OK to go ahead and move forward. Again, if there are things you don't like about those that developed, you then want to go back a step. You can cancel out at this point, go back and start the ForecastBuilder again and skip to that right ahead to the step where you'd want to adjust those, and that would typically mean either adjusting the QPF or adjusting the snow ratio or maybe even temperature to get a better result out of that. We do not want the accumulation grids to be hand edited. much rather have you all edit the foundation grids that go into that. That way it maintains the scientific integrity and the meteorological integrity of the database. All right, once you're satisfied with that, step 5 pops up, and this is the time when you create and update your non-precipitation type grids. Other POT grids are possible depending on your office and the season. For this case, we've got POT fog, POT frost, POT thunder, and POT sprinkles or flurries are showing up for this session. Again, if you don't want any of these to show up, if your weather grids are just going to be pretty plain Jane basic, you can skip the step and use other tools to update. Don't check any of these grids and just press OK. But in this case, we'll go ahead and select the POT fog and POT thunder, run those grids, and here's a video example of that in action. So step 5 comes up, select the POT fog and a POT thunder, press OK. It brings up the POT fog. We're going to switch that to patchy for my example here, and run with the default values in that. And that's operating over the entire domain here. And since we've got some elevation in our area, we'll make adjustments to that later. But right now, gone ahead and done the POT thunder, and we ran with the defaults of that. It's a 1-to-1 ratio, so if you got a 20% chance of precipitation, then you'll have a 20 thunder value will be 20, so you'll have slight chance and slight chance thunder. They match up the same, but you can adjust things, so you could have a likely chance of precipitation and then just a slight chance of thunder or chance of thunder, so you can have those adjustments too. So it's fairly robust with what you can do with that thing. You can also edit the grid directly if you'd like. It's a scalar grid, so it's good for interpolation, good for smoothing. Okay, now once you've done those, you might want to look those over, adjust them as needed, collaborate with your neighbors. Certainly if you're going to affect the boundary of your CWA, coordinate with them as well. And maybe a good idea to get in sync with when you want to introduce thunder and how well related and well correlated with pops you want your thunder to be. So we got an example of that in practice. So for this, gone ahead and I ran it for the entire domain of our CWA, and so we want to take account some of the elevations. We're probably not going to see much fog at on the higher elevations of our CWA. So let's go ahead and turn that on, and we'll make sure that we'll guarantee that those areas have no fog by assigning a value to that. Assign a value of 0. We'll make sure that there is no fog, whereas values of 20 represent patchy, or higher values will represent areas of fog or widespread fog. Essentially what we're doing at this stage is we're building the sub-elements that go into making the weather grid. So you are able to edit those individually on a scalar basis. You have a lot more control over how those operate. And then the final step is when we merge those all together into the final weather grid, which is just like using the hazard grid when you merge hazards. So this is the genius of the POWT platform, is that you're able to break out various sub-elements of the weather grid and adjust those individually. And that means if you decide you want to change any of those those sub-elements of the weather grid, you don't have to wipe out the entire weather grid. You just go in and change that scalar grid, the POT grid, and make those adjustments, and then rerun the weather grid to merge it back together again. Or in this case, rerun step 6 of the ForecastBuilder process to merge those all back together again. Makes for a much easier way to maintain the weather grid and to, again, maintain that internal consistency and meteorological integrity throughout your database. Okay, and the final step is just creating the weather grids. And here you've got a couple of options you can play around with. If you want to change your default probability to coverage, you can change that, all of them, or you can change individual parts of the weather grid to that. You can also raise your intensities of thunder fog or freezing fog. You can add optional attributes for the T in there as well. And therefore, you can, if you only want a small section of this, you can rerun the weather builder at this final step, just over a small area if you want, a small time frame to fine-tune that as well. Also, the severe watches and tornado watches, automatically you can put these in by default. You can turn them off if you want, if you don't want that information contained in your weather grids, but the default is to have them in there. Likewise with flood watches, when you have a flood watch in there, it will take that and incorporate heavy rain into the attribute of the weather grid as well for those areas and for that time frame. So let's go ahead and watch this video example of it. Be patient with it though. The weather takes a little bit longer, and the more weather types you have, the messier the weather situation, the longer it will take. Even in messy weather situations though, you'll come up with a pretty decent weather grid at the end. It might not be as legible as maybe you would like if you're trying to show somebody that specific weather grid, but it will come out well when you're using the point click, and it will work out well in the formatters as well. So even if it looks crazy with all kinds of different colors and weather elements in there, the formatters can deal with that pretty well. Weather grids have been created. You can take a look at them and make sure they're pretty much what you want. Remember, the whole database has already been pretty well finalized and checked over. The integrity is pretty good. So if you're satisfied with that, just go ahead and save your weather grids. You can publish them and send them off to the world and start making your products out of them. You can see the further along I get, we had some fog earlier. Now we've got some thunder sneaking in and some thunder showers in there at the isolated level. You also note that it only has done just your ISC send area for the weather grids. That's to keep down the processing. It runs a little faster if you're not doing it for the whole domain. It tends to be more stable from our experience as well. So that's plenty to get the information out to your neighbors to compare. It's also all you need for sending your grids to NDFD and having them work for the formatters and also the web. Okay, you'll have a banner up there at that process that says ForecastBuilder is complete. You can go ahead and close it. You're all done, and you just save those and send those out. Again, note that my weather grids are hourly just because I have hourly pops in there, and that's a feature of how we have our ForecastBuilder configured. And so you can now save and publish those grids. So that completes your introduction to the ForecastBuilder and your walkthrough of it. This is the full version, so this is the most robust version we have of it. And if you wanted to use the light version, you would skip this final weather step and setting up the POT weather grids. And also skips most of the top-down portion of it. But if you're going through with the full version, you basically have a complete forecast database once you're done with it. So I thank you for listening and watching this video, and be sure to check out other ones we have there for training on this. And you can visit our VLab page, the ForecastBuilder VLab page, and in the forums there you can ask any questions or have any discussions you want about how this is working for your office. So I thank you.